With the name of Allah Almighty, dear students and all viewers, may peace be upon all of you. Hopefully, all will be fine. I am Dr. Engineer Majid Amin from Peshawar, Pakistan, and I welcome you to my YouTube channel, Maths.Physics. We have started this chapter, ninth class mathematics. Chapter is matrices, and today we will have its sixth lecture. The topic which we are going to discuss is multiplicative inverse. So without wasting any time, let's get started. But I tell you that we have already delivered 5 lectures. The link will be there. Otherwise, the whole playlist is in the description. Students, this is a formula to find the multiplicative inverse of a matrix. A inverse is equal to 1 by A determinant into A adjoint. Now, what is inverse? Where did it come from? We will discuss it later on. But first, we will discuss these two things called determinant and called adjoint. All right, students, determinant of a 2 by 2 matrix. For example, you are given this matrix, a 2 by 2 square matrix, because the topic determinant is for a square matrix, maybe 3 by 3, maybe 1 by 1. For the time being, we are discussing for 2 by 2 matrix. The symbol for determinant is this thing. We say determinant of A. How pronounce it? How to pronounce A? Determinant of A is equal to A, B, C, D. Determinant. Multiply these two elements of principal diagonal, then put minus and then multiply these two. For example, my sweet students, this is matrix, a 2 by 2 matrix. 4, 3, 6, 5. My sweet students, A determinant 4, 3, 6, 5. Determinant of A. Multiply these two, then put minus sign and then multiply these two. You get 20 minus 18 is equal to 2. Now, often the students, they keep on wondering, sir, why is it so? Why do we put negative sign after multiplying these two and then put minus sign? Where does it come from? Or if it is so, why don't we say multiply elements of first row, then put minus sign and then multiply elements of second row? Why specifically we say multiply these two, then put minus sign and these two elements of principal diagonal, product of elements of principal diagonal minus product of elements of the secondary diagonal. This is called principal diagonal, then minus, then it is called elements of secondary diagonal. So students, let me tell you, there is a proper procedure for calculating determinant. Determinant is just a number associated with every square matrix. And there is a proper way, there is a method called cofactors. We define the properly determinant of matrix in first year, that if you take elements of a row, for example, these are elements of the first row, and then we will multiply them with the corresponding cofactors. I have delivered these lectures with full detail in my first year level. Link will be there, but unfortunately it is in Urdu, our own national language, not in English. But I'm just telling you that there is a lengthy procedure, what is determinant and how to calculate. So you take elements of a row or column and then multiply with corresponding cofactors, which if you have no knowledge, forget about these cofactors, A1, 2, I'm really sorry, and then add them. The result will be called a determinant. But if you go through this proper procedure, at the end you will get a result, which will be this thing. So for 9th class students, we bypass that method, that procedure, that headache. We bypass that procedure and at the end write directly the result which we will obtain after going to the procedure. So you have to remain confined to your 9th class level. You can't discuss things which you are supposed to study at a higher level. So it's better that forget about these things, where it comes from and why do we multiply this or this. Just say, okay, it is given in our book in this way. Multiply these two, then put minus sign and elements of secondary diagonal like that. A determinant 20 minus 18 is equal to 2. That's it, enough for you. Don't discuss things which will come later on in your high levels. Now, what is meant by singular matrix? Singular matrix, a matrix whose determinant, DAT shortcut determinant, is equal to 0. And non-singular matrix, determinant is not equal to 0. Like that one is non-singular matrix. That one is non-singular matrix. And for example, if I give you this matrix, let's say minus 1, 2, minus 3, 6. For example, let's call it matrix B, then determinant of B, minus 1, 2, 3, 6, multiply these two, minus 6, minus, multiply these two, minus 6 plus 6 is equal to 0. That's it. So B is a singular matrix because its determinant is 0. And it is a non-singular matrix because its determinant, whatever is the determinant, but it has to be non-zero for a non-singular matrix. Right, students? I think you got the main idea. All right, students. Now, what is meant by adjoint of a 2 by 2 matrix? That's what I've written, adjoint. Let's say you are given a 2 by 2 matrix, a matrix obtained by interchanging elements of the principal diagonal, means change their places, dA, and changing the signs of the elements of the secondary diagonal, minus B minus C. That is called A adjoint. That is called, students, what? A adjoint. That is called A adjoint. Now again, once again, sir, what will happen if we have a 3 by 3 matrix? So this is not the proper, this is just the shortcut method to arrive at the result. The proper definition is transpose of the matrix of the cofactors. Of course, these methods can't be applied for high order matrices. What if you have this matrix 3, 1, 9, 2, 6, 5, minus 8, 4, let's say 8, let's say this is the matrix. How to calculate its determinant? How to calculate its adjoint? Of course, once again, to be discussed at first year level, intermediate level. There, you will come across these topics, determinant, adjoint, inverse, ultimately inverse topic we will discuss for high order matrices. Here you just study 2 by 2 matrices. There is a proper way we say A adjoint is transpose of the matrix of the cofactors A11, A12, A13 transpose A21, A22. For those who are curious about this, A31, A32, A33, A33. Right, students? This method can be applied to 2 by 2 matrix as well. And this result comes from the application of this definition, transpose of the matrix of the cofactors. No need. Let's say we have this matrix A. So its adjoint will be A adjoint will be interchange the elements of principal diagonal 5, 4 and change the signs minus 3, minus 6, A adjoint. Students, finally inverse. This is A adjoint, that's it. Change places, change signs. Now, I will write the definition of multiplicative inverse, but this is the formula to calculate the inverse. First, you should know how to calculate the inverse. For that particular matrix, A inverse will be equal to 1 by A determinant into A adjoint. A adjoint 5, 4, minus 3, minus 6. This is what? This is A adjoint. My 5, 4, minus 3, minus 6. You can multiply this number as well. You will get 5 by 2, minus 3 by 2, students, minus 6 by 2, 4 by 2. Then you can write this as 2 and this is minus 3. You got the point. All right, students, this is called scalar multiplication. In the previous lecture, you discussed multiplication of two matrices. This is called scalar multiplication. Scalar means constant. Means if you are multiplying a constant with a matrix. Let's say this is a constant you are multiplying with a matrix. The matrix may be a square matrix, maybe rectangular matrix. The point is that the constant will be multiplied, the scalar will be multiplied with all the elements, with all the entries. Ka, Kb, Kc, Ke, Kf, Keg. Like this, you multiplied this constant with all the elements. Scalar multiplication. Students, I tell you that a giant adjoint and determinant and inverse. These things are defined for square matrices only. Square matrices only. Even it can be a one by one matrix, like we say, if we are given a one by one matrix, then its determinant will be the element in the matrix. Determinant of one by one matrix is the element in the matrix. If there is four, a determinant will, if it is minus four, it will be minus four. But then, of course, we have two by two matrices at ninth level. Don't go beyond your limits, I suggest. And I will continue this until FSC, BSc, and English. I've given the courses of FSC and somehow BSc as well, but in Urdu. This is called A inverse. Now, what is inverse? What is inverse? It is a matrix. All right, students, what did I write? Multiplicative inverse. It is a matrix that when multiplied with the given matrix gives identity matrix. Means that A multiplied with A inverse will be equal to identity. For example, at the beginning, he tells you find A inverse. It's okay, we have this formula, but even before starting your solution, you should know your ultimate destination, what you are going to find, what actually he wants. He wants that what matrix should be multiplied or must be multiplied, which matrix will be multiplied with this matrix to get identity matrix. We know what is identity. Elements of principal diagonal are 1, other elements are 0. If we have 2 by 2 matrix, identity will be this matrix. So which matrix will be multiplied? Yani, I mean that you can ask the question like this: which matrix will be multiplied with this matrix to get identity matrix? So this matrix which we will multiply with this matrix is called inverse of that matrix. We say this is inverse of this, or this is inverse of this. So the same thing. But which matrix should be multiplied with this matrix to get identity? So the matrix which will be multiplied with this to get identity will be called multiplicative inverse. So just think over that. What if we didn't have any formula like this? Just imagine if we had not been given this formula by our elder mathematicians, by our forefathers, then how would we find this matrix? How would we find this matrix? It's almost impossible. And just imagine if I give you a bit difficult matrix like this, it's almost impossible for you to find this matrix if we multiplied with this to get identity. And you know, there is a method to the madness, idiom of English. There's a proper way to solve some given problems. So to arrive at that matrix, we have developed these so-called determinant and adjoint and this formula. So ultimately, the matrix which we wanted to calculate is that matrix. Now you may verify, my sweet students, 4, 3, 6, 5 multiplied with this 5 by 2 minus 3 by 2 minus 3, 2. Multiply first row with first column, Multiply them 20 by 2. Of course, I will write in minus 9. All right, students, what is this? Multiply these two. Minus 12 by, students, minus 12 by 2 plus 6. Second row, first column, 30 by 2 minus 15. These two, minus 18 by 2 plus 10. Minus 18 by 2, 18 by 2, 9, 15, 10. 10 minus, this is 6. You see, students, 1, 0, 0, 1. Identity. And if you take A inverse first, followed by A, the same thing. In the previous lecture, we discussed that commutative law of multiplication doesn't hold in matrices, means AB will not be equal to BA generally. Generally, we have discussed these things, no need. So we said that in special cases, in minority of cases, AB can be equal to BA. And one case among those minority cases is this case. If this matrix has inverse of this, even if you take this matrix first, followed by this matrix, and then multiply, you will get the same result. All right, students. Then there is a short theorem which says that inverse is unique. Inverse is unique. How to prove that? Unique means particular. Means you can't have two things. Like we say our father is unique, our mother is unique. We can't have two fathers. This one is my father and that one is my mother. That's it. We can have five brothers. This is my brother, this, these are my five brothers, these are my three sisters. But we can't have two mothers. The thing which can't be, which is only possible in one, it is called unique. That thing is unique, father is unique. Allah is once, Allah is unique. So my sweet students, inverse is unique. To prove this, let A is a matrix. And we have two inverses. And we have two inverses B and C. We suppose that there are two inverses B and C. He says, show that inverse is unique. I suppose that there are two inverses B and C. Then A multiplied by B will be equal to identity, because matrix multiplied with inverse will be equal to identity. How will you pronounce this? A inverse means the inverse of A. A is a matrix. This is A and that one is inverse of A. So you have supposed that B is inverse, so A times B will be equal to identity. Similarly, A times C will be equal to identity because both are inverses. Compare 1 and 2. Compare 1 and 2. From 1 and 2, we have AB is equal to AC. Cancellation law holds in matrices, or we say multiplying both sides. Cancellation law holds in matrices. So B is equal to C. B and C are equal. It means they represent the same matrix. Like if B is this, so if two things are equal, it means that they are the same matrix. They are equal. It means it is the same matrix. One matrix written twice. So if two things are equal, we say it is unique. B and C here, they represent inverse. So we say that inverse is unique. My sweet students, I think enough in this lecture. My dear students, I forgot to tell you this important point. For singular matrices, inverse is not defined. Inverse matrices are not defined. What does it mean? For example, and of course, you have this formula, A inverse is equal to 1 by A determinant into A adjoint. What if the matrix is singular? Singular matrix means whose determinant is 0. So if A is singular, its determinant will be 0. And students, you know, anything by 0 is undefined. For example, and further it means that, for example, it is a matrix A. Its determinant is clearly 0. 10 minus 10 is equal to 0. We say its inverse is not possible. It is a singular matrix. It means that it's not possible to find a matrix which, when multiplied with this matrix, will give me identity matrix. This matrix is not possible. This matrix is not possible, my sweet students. It's not possible to have a matrix multiplied with this to give us identity result. Means that inverse will be always for non-singular matrices. Matrices, non-singular matrices, for non-singular matrices, we can find the inverse. Because adjoint will be some matrix like 2, 3, 5, 4. So ultimately 1 by 0 has to be multiplied with them, all the elements, and you know anything by 0 is undefined. It is undefined. This important point I forgot, but it's okay. I will include in the video. Don't worry. But it was important point. Let's discuss. Let's continue our lecture. We will meet in the next lecture. Maybe I will discuss transpose and its properties, or I may discuss solution of system of equations. Till then, remember me in your prayers. Allah Hafiz.